Hello, wonderful students. It's Mrs. Bodell here, and we're looking at Chapter 1, Lesson 7 in MyMath 1.7, and we are on page, if I can get there, 49. We are on page 49. So we're going to get started with our math. Today we're looking at comparing decimals. So we're still talking about how the position of a digit relates to its value. So this girl here in our example is listening to music. Well, maybe this is a guy. Okay, Luis downloaded 2 songs onto his MP3 player. Which song is longer? So song number 1 is 3.6 minutes. Song number 2 is 3.8. So we're going to compare which one of those is longer, which one is bigger or greater. So one way we can use is a number line. So here's our number line, and it goes forever this way. So there'd be 3.4, 3.3, all the way down to 3. Then after 3.9 comes 4, 4.0, 4.1, 4.2, 4.3. That goes on forever, both directions. And we're going to look at the points, 3.6 and 3.8. Everything this way gets bigger. So since 3.8 is bigger, 3.8, our alligator eats the bigger number. Remember, he's got his teeth here. He likes to eat the bigger numbers. So there's our alligator. And so 3.8 is bigger than 3.6. This is the way that I want you to do it, because this is the way that's going to help you. Line up the decimal points. Line up the decimal points. I ask you to say out loud right now, line up the decimal points. Say it one more time, line up the decimal points. I'm going crazy on that because as you continue doing math, if you don't line up the decimal points, you're going to have a really hard time comparing numbers. It's pretty easy when you line these two up and you see that these are both in the ones digit and these are both in the tenths. Both in the tenths. And so we're always going to start comparing at the greatest place. The one digits are the same. We have both 3s in the ones digits. So we move to the next. We continue comparing until the digits are different. So in the tenths place, 8 is greater than 6. So that whole number, 3.8, is greater than 3.6. So song number 2 is longer. This is no different than how we compared whole numbers. So if we had 242 and 241, we'd start here, compare, they're the same, move to the next one, compare, they're the same, move here, 2's bigger, so that whole number is bigger. That is no different from what we're doing. It doesn't matter that there's a decimal point now. We're going to do the same exact thing. Let's go to the next page. Decimals that have the same value are equivalent decimals. So equivalent kind of looks like equal at the beginning. It means equivalent values. They're the same value. So 8 out of 10, or 0.8, is the exact same thing as 80 out of 100, or 0.80. So here's our one whole size. Say this is a sheet of brownies, okay? And we've got this pan of brownies. If we divide it into 10 slices, very thin slices, and I give somebody 8 of them, I've given them that much. Well, if I take that same size sheet of brownies, but this time I divide it into 100 little tiny bites, and I give this person 80, it's the same value. You see that this is the exact same size. 8 tenths is the same thing as 80 hundredths. 0.8 is the same thing as 0.80. The models show that you can annex or place zeros to the right of a decimal without changing its value. This annexing a decimal could go on forever. I could go 0.8, 0.000000000000000. I can put as many of those as I want on that side of the decimal point next to the last digit, and it doesn't change its value. So let's take a look at the examples. Write greater than, less than, or equal to in the circle below to make the sentence true. So we've got 8.69, and it wants us to annex a 0 so they have the same number of decimal places. So let's just make this 8.69 and 8.60. So if we follow our rule and stack up the decimals, 8.60, we could start here and go, oh, that's the same, let's go to the next digit. Oh, that's the same, let's go to the next one. 9 is greater than 0, so that whole number is bigger than the other. Lining up those decimal points is going to be extremely important. So let's do our guided practice. We're going to write greater than, less than, or equal to in each of the circles to make it a true sentence. This time it's going to have us use a number line, and this is helpful because sometimes we have to put things on number lines. So here's 0, 0.0, and here's 1. We know that 0.5 is about half. It's halfway between 0 and 1. So where is it? 0.1, 0.2, 0.3, 0.4, 0.5. Okay, so there's that spot. And then we have 0.7, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. Okay, so remember on our number line you get bigger going this way. So which one is bigger? 0.7. And let's do this one down here. We have 4.40 and 4.44. So here's 4.40, 4.41, 4.42, 4.43, 4.44. There's our other number. Which one is bigger? The one further this way. So that one is bigger. The alligator eats the bigger number. Pause there if you need more time, and we're going to go on to the next page. We're going to plot each decimal on the number line. This is just what we just did. So we have our number line. This goes between 4 and 5. I always like to take a look at where we're starting, just so we kind of know what's taken place on this number line. So we have 4.4, 4.1, 4.2, 4.3, 4.4, and 4.1, 4.0, 4.1. So which one is bigger? This one, right? 4.4. So our alligator eats the bigger number. Okay, let's do number 4 together. Okay, so we're going 0.30 to 0.40. So we have 0.37, 0.37. So let's look at the pattern here. 0.30, 31, 32, 33, 34, 35, 36, 37. And 0.39. 0.39, which is the bigger number? This one to the right, the alligator eats her bigger number. Let's pause here. I would like you to complete number 5 on your own and then come back and check your work. On number 5, I graphed 0.57 right here and 0.65. We're starting at 0.55 and going up to 65. My bigger number is definitely that one. It's pretty far away. Okay, these are also going to be greater than, less than, or equal to, but this time we're going to stack them up. We might have to annex a 0, and remember, annexing a 0 is adding zeros. So let's just stack it up over here. So we've got, line up our decimals. So 2.15, and let's annex a 0, because remember we can add as many zeros on the end of this as we want. Now let's compare our digits, starting in the greatest place. 2 and 2, same. 1 and 1, same. 5 and 5, same. 0 and 0, same. It's going to keep being same, 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 which means they are equal. Okay, let's line up our decimals here. I'm going to move it over to this side. So we've got 0.1. Let's line that up. 0.1. And now we can annex or add some zeros here so that they have the same number of digits. Now we start at the greatest place. 0 and 0, same. 0 and 1, which is bigger? 1. So this whole number is bigger. It doesn't look bigger. That one has a lot more digits, but the value of this is bigger. And if we look at our our decimals here, 6, this top one is 6 out of 1,000, and this bottom one is actually 100 out of 1,000. So that's definitely bigger. Okay, let's do number 8. We're going to stack them up. You can go either way you want. I like to write nice and neat underneath. If you want to draw lines like this to help you keep it nice and neat, that might help you out. 0 point, I'm going to write 647, 647. So now we start comparing. 0 and 0, same. 6 and 6, same. 5 and 4, which is bigger? 5. So that whole number is bigger. Okay, let's go ahead and pause here, and we're going to do number 9, number 10, and number 11, and then we're going to come back and check your work. Okay, you guys, I have I've stacked up my decimals nice and neat so I can compare these digits. Remember, I can annex or add a 0 to the end of any of these after my decimal to make sure that they look the same, that they have the same number of digits. So if I compare here, we have on number 9, we have both zeros the same, both zeros the same. 9 is bigger than 0, so that whole number is bigger than the one next to it. On number 10, I've stacked them up. My ones digit, 7s are the same. My tenths digit, the 3s are the same. In the hundredths, I have a 1 and a 0. Which is bigger, 1 or 0? The 1 is, so this whole number is bigger. When I stacked this one up and annexed my zeros, you can kind of glance and see, that's the exact same number, huh? So it is. 2.8 and 2.800 are the exact same number. Let's check and finish this with number 12, 0.7 and 0.5. I lined them up. My ones digit is the same. 7 is bigger than 5. So 7 is the winner all the way. Let's line up this. We'll go this way, 0.26. My zeros are the same. Which is bigger, 6 or 2? 6 is bigger. That whole number is bigger. This one, let's go this way, 3.7, and I can annex a 0 at the end or add a 0. So that is the exact same number, 370, all the way across. Great work. If you need to pause here to check your work, you may do so. If not, we're going on to the back page. Okay, so this one says, for exercises 15 through 17, we're going to use this table that shows the cost of posters around the famous works of art. So it's always important to read these things. So this is the poster prices. So here's a poster, and here's how much it cost. So these are going to be the names of posters, and this is going to be the cost of each one. Does the poster Relativity or the poster Women and Bird in the Night cost more? So we have to go back up to our table. So here's Relativity, and here's Women and the Bird in the Night. So we're going to compare these two values. Now remember, decimals are just like money. This one is $11.49, and this one is $18.98. We're going to compare which one is bigger. We have our decimals lined up. We have ones in the tens digit, and we have a 1 and an 8 in the ones digit. So this is definitely bigger. And I bet you guys knew that just because $18, you know, is more than 11. So it doesn't want to know the cost, though. It wants to know which poster. So the poster is Women and the Bird in the Night. Okay. Feel free to pause it there if you need to catch up and write that out. Number 16, which poster costs less? Which one is less? From the lake number 1 or water lilies? So we have to go up to our chart and find from the lake number 1. Okay, so that one's $16.99. And I'm going to put F for from the lake so we can keep track. And then water lilies. Water lilies is here and it's $15.99. And I'll label it water lilies, W. So we've got our decimals lined up. We compare the tens first. They both have a 1. And then we go to the ones. This has a 6. So that one's most expensive, but it wants to know which costs less. So it's actually this one. So we're going to write our word up there. It's water, and it's also written right there so you can look right above it. Water lilies cost less. When you think of decimals as dollars, it's sometimes a little bit easier to compare them. Okay, it wants to know which poster costs less than water lilies. So we know that our water lilies is $15.99 because we just wrote that. And we know that this one is not. What about women and the bird in the night? 18 something. No. What about this one? Let's check it. Let's line up our decimals. Yep. Relativity is less. It costs less than water lilies. Okay. Hot problems. We're just going to do one, and it's tricky, so we're going to talk it through. It says, how many times greater is 46 than 0.46? Whew! That's a tricky one. So we've got our number 46 here, and we've got 0.46. Now, I know that every time something moves this way, it gets 10 times bigger. So it's definitely getting bigger because, look, there's our decimal point in 46. It's 46.00, 46 even. But how many times did it do that? So if we multiplied 46 times 10 with our calculator, we'd get $4.60, 4.60. If we multiplied 4.60 times 10, we'd get 46. So 10 times 10. What's 10 times 10? 100 times bigger. We're going to be doing more of that. We just want to get you guys thinking about how every jump of a decimal point is 10 times bigger. Great work today, you guys. You do not have to do this last question, and I will talk to you soon. Thanks.